Welcome to Your Math Explained, where we make math simple and clear. My name is Julian, and today we'll look at two nice geometry problems that demonstrate some well-known facts. The first problem is for grade 9-10 students, and the second problem is for grade 11 and 12 students. In both problems, we rely on properties of triangles to arrive at our answer. Pause the video now if you haven't had a chance to read it, otherwise let's jump in. In this problem, we have a triangle, and we're given that some of these sides are the same, so they've been marked with a hash on these sides. And we also have an angle Z, and our goal is to figure out what angle PSQ is, so PSQ being this entire angle up top. And the first thing that I notice here is that I've got two isosceles triangle. So this one and this one, they have the same sides. That tells us that this angle and this angle must be the same. I also know that there's another isosceles triangle, PRS. So that also tells me that this angle and this angle must be the same. We can create some relationships using those two isosceles triangles. So from triangle SRQ, the fact that it's isosceles tells me that angle QSR, and I'm wanting QSR because that's going to help me find the end goal of PSQ. We see that QSR is part of angle PSQ. So what do we know about this angle here? Angle QSR is equal to 180 degrees minus Z. So the reason for the 180 is because the angles in this triangle add up to 180. We're subtracting the Z, and then just to find one of them, we're going to divide that by 2 because we know the remaining two angles are the same. Similarly, from triangle PRS, the fact that it's also isosceles tells us that angle PSR, which is the angle on the top, that is also equal to something subtracted by this value. So I think we want to figure out what that number is first. And we're going to rely on another property. So angles on a line. So when I draw this green line here, the angle here forms 180 degrees. So if we know that this is angle Z, then we know this is going to be 180 minus Z. What we would like is 180. That's the angle in triangle PSR. That's what it would sum to. We're going to subtract the 180 minus Z and then divide it by 2 to give us the remaining PSR value. When we simplify this, the 180 and the 180, that will cancel out and we'll just be left with Z over 2. Finally, we would like to find angle PSQ. So what we see in this diagram is that angle PSQ is angle QSR plus angle PSR. So adding the two results together will give us 180 over 2, which works out to 90 degrees. And that would be the value of the angle of PSQ. And this leads us into our extension problem. So this one has no numbers in them, but what we can observe here is that AO is the radius. That is also equal to OC, that is the radius. That is also equal to OB, which is also the radius. So if those three sides are the same, then we basically have recreated the situation that we just completed earlier, but this time it's inside a circle. That tells us that this angle up at the very top, that is going to be 90 degrees. The result is often expressed as a theorem for circles. This is usually stated as an angle inscribed in a circle by a diameter of the circle is 90 degrees. So an inscribed angle would be this one that's created from the diameter. That's going to create a 90-degree angle. In our grade 11 and 12 problem, it would benefit us to probably draw some additional lines so that we get some radii to work with. So I'm going to draw a line segment C to D, and we'll notice that this is the radii. This is also a radii. And I think that's all the line segments that we need. This one up here is also a radii. So let's maybe give some names to the angles that have been created. So if I look at triangle ACD, I see an isosceles triangle. I'm going to call this one Y. That means this one over here would also be Y, because those are the angles formed with similar sides. In addition to that, we see BCD is also an isosceles triangle. So if angle CDB here is x plus y, then we also know that this one should be x plus y. So again, we're relying on isosceles triangles to help us. So our job is to figure out what angle ACB is, ACB being the angle that's right here. So if we can somehow create a relationship to get to that angle, we'll be happy. What we notice is that we can probably try to find angle ACD, similar to our grade 9-10 problem. We're also going to try to find angle BCD, because that'll get us the angles that are close to the resulting angle that we want. So let's see what kind of relationships we have currently. When I look for angle BCD, well, because that's an isosceles triangle, I'm going to have 180, and then we're going to take away the x plus y and the x plus y, and that would leave us with the remaining amount. So that's taking away 2x minus 2y. We can do something similar for angle ACD. So if we take a look at triangle ACD, we've got y, and then we're going to have 180 minus those two things. So we'll have 180 minus 2y. And since our job is to find angle ACB, we see the relationship is created by taking angle ACD and then subtracting angle BCD. So that would give us 180 minus 2y. And we're going to subtract 180 minus 2x minus 2y. We see the 180s will cancel out, the minus 2y plus 2y will cancel out, and we're just left with 2x. So we see an interesting result here where this angle C is actually 2 times angle x. In general, the angle that's inscribed at the center of a circle is twice the size of the angle that's inscribed at the circumference by the same chord. That is, the angle inscribed by chord AB. So the chord AB would be this guy right here. We can see that it's being generated by angle X. We call that an inscribed angle. Alternatively, we can see that chord AB can also be described as being inscribed by the central angle C. So this central angle is going to be double the inscribed angle. And then that's a well-known circle geometry property. That wraps up this week's problems. Check out the problems I've posted for next week's video. Try them on your own first and see how you'd approach them. And as always, if you found this helpful, don't forget to give this video a like and subscribe so you don't miss the next one.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.